So here are a few applications of our log properties. Okay, our adding our logs is the same as adding exponents. So we have to first of all make sure, do we have the same base? Yeah, we've got the same base. We can apply log properties here. And when we add these together, we are going to take the arguments and multiply the arguments together. Okay, so that all is now in one argument, and that is okay. Converting from logs to exponents. If you want to use a definition of log, there's two ways to get rid of logs and to introduce logs. One is logging both sides of the equation. The other is converting from exponential function to log function, to log expression. So one way, if I'm going to use a definition of log, this does not fit. I've got a base, I've got an exponent, I've got an argument, and I've got an extra piece here. That does not fit our definition of log. So if I'm going to use definition of log, I have to do this first. So I'm going to rewrite this. Okay, I'm going to divide both sides first by 2. Now I have a base, an exponent, an argument. Okay, so then there's my base, there's my argument, and there's my exponent. I can now convert that to log expression using the definition of log. Okay, so that's going to be there. I'm just going to color code some of this. That's my argument, that's there, and my base, that's my base here. Okay, so we've got all three parts there clearly defined. Okay, so that's perfectly fine. Now, if I were to, I could also introduce logs by logging both sides. Now, ideally, we probably should get rid of that 2 to the other side, but even if I log both sides here, that's okay. Okay, here I'm using a base 10 log. That's all inside the log. Okay, because I can have log of that whole left side equals the log of the whole right side. Now, if I want, I can, and that's perfectly fine to do that. If I want to do something with that exponent, I'm going to have to separate that times 2 out with a log property, and then I can bring the exponent down as x minus 2. Okay, so I can introduce logs in this way too. So these are two different strategies. Okay, these are two different strategies. One is definition of log. Right, this is using definition of log. This is logging both sides on this over here. This is log on both sides. So these are different strategies to introduce logs into an equation. Converting to an exponential expression. I can drop logs to put it into, get rid of the logs to have an exponential expression. If I want, I can maybe move that to the other side, right? Cross multiply, because that's divide. I cannot divide x divided by a. Okay, we don't want to do that. That's one of the errors that I kind of pointed out at the beginning. Here, dividing logs is change a base. So I could change the base. I'm going to do it 2 ways. Okay, so this is change a base. And then I'm going to convert to an exponent after I change a base. So change a base is going to be 2 log. Base 2, I'm going to, the denominator base, as long as the bases here match, right? The base here and the base here match. This is a change of base formula. So I'm going to make the denominator the base and the numerator the argument. And then I can apply the power in. And then I can convert to exponent like that. Okay, now there's nothing saying that I couldn't have put this times 2, which ends up as a squared here, as a divided by 2 on the b, which would have ended up with as a square root on this side. Okay, so notice that it ends up as squared on this side. Well, if it ends up on this side, it would have been a square root, which is perfectly fine. This is the inverse operation. Okay, so I'm just going to leave it like that. But like I said before, there's many different ways we can apply these log properties and get the same result. Okay, they may look slightly different, but the algebra is perfectly fine as long as you don't make something up. Okay, so here I'm going to use, since it's divide, okay, there's no rule for divide logs, I'm going to move that over to this side. Okay, so I'm going to do like this, equals b log base 2 of a. Okay, so I cross multiplied there, and if I can put those exponents inside, I'm going to, I can just drop the logs and I get x squared equals a to the power b. Now, I want to show you what happens when this 2 ends up on this side of the equation. This is a power 2 on this side. Okay, well, if it's a power 2 on one side of the equation, if I undo it, I should get square root on this side of the equation. Okay, so just make sure that the algebra, I'm doing times divide algebra, I'm dividing. Okay, so that power 2 on the outside is using regular algebra. When it goes inside, it's using exponent algebra. Here, this divide 2, yeah, I divided, that's consistent. But when I put it inside, it's going to show up as a square root. And that is perfectly legitimate. Okay, because a squared on this side, if I undo this squared to get an x, I have to square root on the other side as well. Okay, and those are two equivalent expressions. Now, if I want to make them the same, I would just go ahead and get rid of the square root with a square, and there it is, x squared equals a to the power b again.